Example 3, inverse functions. Take a moment to write all this down. You can pause the video if you need more time to write. So if f of x equals x, then it is called the identity function. This is a similar idea to the multiplicative identity, which is a times 1 equals a. So just like that multiplicative identity, we can relate it to functions. F of 1 of x equals f of x. So then we can take that idea and apply it to how we know if two functions are considered inverse functions. So if f of g of x equals x and g of f of x equals x, then we can say that f of x and g of x are inverse functions. We are going to look at this graphically, but today we're just going to look at it algebraically. So for our first example, we're going to be using the functions f of x equals x plus 4 over 2 and g of x equals 2x minus 4. And we want to prove f of x and g of x are inverse functions. All right, so to prove this, we need to do two steps. The first step is to do f of g of x. And we want to make sure that f of g of x equals x. If that's true, then we can move on to the second step, which is doing g of f of x. And if that equals x as well, then we know they're inverse functions. If they don't equal x, then we don't have inverse functions. All right, so starting with f of g of x. So the f function is x plus 4 over 2. But remember, when you're doing a composition, we're replacing x with the g function, which is 2x minus 4. So now we can go ahead and simplify this expression. The 4's cancel, leaving us with 2x divided by 2. And 2x divided by 2 is 1x, or x, so x does equal x. All right, for the next one, we're going to do g of f of x. So we're just going to bring down that right side, the g function. The g function is 2x minus 4. But instead of the x, we're going to replace it with the f function, which is x plus 4 divided by 2. When we go to distribute that 2 through the parentheses, the 2's just end up canceling, and we have x plus 4 minus 4. The 4's cancel, and we're left with x, which does equal x. So then we would say, therefore, f of x and g of x are inverse functions. All right, let's do a you try. All right, pause the video, and then when you're ready to check your work, you can hit resume. All right, so to prove that these are inverse functions, we need to do p of q of x, and we need to do q of p of x. All right, so p of q of x, that's going to be the p function, which is x over 2 minus 3. And instead of the x, we're going to replace it with the q function, which is 2x plus 6. We're going to simplify 2x divided by 2 and 6 divided by 2. We get x plus 3. Bring down that minus 3. The 3's cancel, and we get x. So this P of Q of x equals x. Okay, let's look at the next one. Q of P of x. So first we start with the Q function, which is 2 times x plus 6. Instead of the x, we're going to write the P function, which is x over 2 minus 3. We'll start with the distributive property. We get 2x over 2 minus 6 plus 6. The 6's cancel, and 2x divided by 2 is just 1x. So that means Q of P of x equals x. So yes, we have inverse functions, so we would just write that. Therefore, P of x and Q of x are inverse functions.